Good morning, one and all. Now I am taking some problems on Cauchy's nth root test. Okay, here how we can apply the Cauchy's nth root test and how we can find out for these problems this exactly Cauchy's nth root test is suitable. Okay, I am giving clue how we can identify on which series is applied to the this Cauchy's nth root test especially. Okay, here test for the convergence, the first one is sigma n plus 1 by n plus 2 whole power n x power n. Here if it is power n is there, we can apply the Cauchy's nth root test. Why? Because the Cauchy's nth root test statement is let sigma un is a series of positive terms such that limit n tends to infinity un power 1 by n is equal to L. Okay, then the first condition is if L is less than 1, sigma un is convergent. If second one, if L is greater than 1, then sigma un is divergent. The third one is if L equal to 1, the test fails to decide the nature. The test fails to decide the nature of given series. Okay, this is a statement of the Cauchy's nth root test. If we have an idea about the Cauchy's nth root test, then we can go for easy to solve the given series by applying the Cauchy's nth root test. Simply you can observe limit n tends to infinity un power 1 by n means if we take the nth root test, then n into 1 by n it is 1, n into 1 by n it is 1. Okay, in such cases here given series is let sigma un is equal to sigma n plus 1 by n plus 2 whole power n into x power n. Here x is greater than 0. Okay, now un is equal to n plus 1 by n plus 2 whole power n into x power n. Okay, now we can take the nth term, nth root of un power 1 by n equal to n plus 1 by n plus 2 whole power n into x power n whole power 1 by n. Okay, now we write separately n plus 1 by n plus 2 whole power n into 1 by n to x power n into 1 by n and n get cancelled. Okay, un power 1 by n equal to here 1 only. In the numerator taking common n, that is 1 plus 1 by n. In the denominator is also taking common n, 1 plus 2 by n into x. This is power 1 means 1. n cancel. Next take the limits n tends to infinity on both sides. Then limit n tends to infinity un power 1 by n is equal to limit n tends to infinity 1 plus 1 by n by 1 plus 2 by n into x. If we apply the limits, then it is equal to 1 plus 1 by infinity by 1 plus 2 by infinity into x. It is 0, it is 0, 1 by 1 is 1, 1 into x. Is x is greater than 0. If x is greater than 0 means that is a positive value. Okay. Therefore, by Cauchy's nth root test, here the given series is depends on the x value. That is here this x is equal to L, L is exactly greater than 0. Why? Because greater than 0 means x is related with the greater than 0. So, by the nth root test, if the first condition x is less than 1, then sigma un is convergent. And the second one, if x is greater than 1, then sigma un is divergent. Third one, if x equal to 1, the test fails to decide the nature of the given series. Why? Because here x is greater than 1. We don't know what is the value of x. If it is the value of less than x, that is 0 to 1 is also in between, some less than 1 values are there. So it is x value is less than 1, simply we can say that the sigma un is convergent. If x is greater than 1, we can say that the sigma un is divergent. If x is equal to 1, then the test fails to decide the nature of the convergent. Okay, this is a procedure. In the same way, we can apply the second one also. Okay, the same series sigma un, the Cauchy's nth root test theorem statement is, let sigma un is a series of positive terms. Here, in the second problem, we can take un is equal to sigma un is equal to, here in this, the nth term is n plus 1 whole power n by n power n plus 1 into x power n. Here un is equal to n plus 1 whole power n by n power n plus 1 into x power n. Next we can take the nth root of un, then this is equal to n plus 1 by n power n plus 1, n plus 1 whole power n by n power n plus 1 x power n whole power 1 by n. Un power 1 by n equal to n plus 1 whole power n into 1 by n x power n into 1 by n by n power n plus 1 whole into 1 by n. It is equal to n plus 1 whole power 1 x power 1 by n power n by n is 1 plus 1 by n. Okay, here applying the limits, limit n tends to infinity un power 1 by n equal to limit n tends to infinity. Here it can be written as n common 1 plus 1 by n into x. In the denominator it can be written as n power 1 into n power 1 by n. N get cancelled. Now we can take the limit n tends to infinity 1 plus 1 by n into x by n power 1 by n. Now we can write the limit values 1 plus 1 by infinity into x by infinity power 1 by infinity, that is equal to 1 plus 0 by infinity power 0 into x, that is infinity power 0 means that is the 1 by 1 into x equal to x. Here x is equal to L, that is the greater than 0. Okay, and again by the Cauchy's nth root test, the value of L is equal to x only. So the convergent and divergent and fails of the test is depends on the x value. If x is less than 1, then the sigma un is convergent. If x is greater than 1, that is the divergent. If x equal to 1, the test fails to decide the nature. Okay, this is a way we have to do the problem by using of the suitable test. In this we can have the idea about the, by observing the question we can easy to choose which test is suitable on that problem. Okay, If we get the idea, then we can easy to solve the problem and carries the marks. It is a 5 marks question. Okay. If you like this video, please subscribe my channel and share to your friends. Thank you.